This is the second part of the Michael Yee Audio PA1 amplifier review, and I call it the solid state amp of the decade because it truly is. It's a very exceptional power amplifier. You guys know probably that I'm a really hardcore tube amplifier guy, and I'm really excited by this amp. And and it's a solid state amplifier, so that's really unusual. Usually people are really polarized and they belong to a camp or the other camp. I don't view myself to belong in any camp. I like music, equipment that does produce music, and what it uses is really secondary to me. I really love to build tube amplifiers because I know how to design them, how to build them, how to modify them. I do not have that skill with solid state amplifiers, but based on my knowledge of electronics and audio, I still can soup up solid state amps. So I know like how power supplies work, how electromagnetic fields are radiated, what each component does, and with that we can make modifications that increase the result, the performance, no matter what the topology. And that's what I showed in my previous video, what were the tweaks that I did for this amp. So now let's have a look at the inside. And as I showed the last time, these vials here and these capsules and the shields around the capacitors, the power supply filter capacitors, are my modifications, and also the wires, they have been changed from the original ones. But now I'm not going to talk about this, but I will talk about the stock amplifier. So what Michael Yee did to make this amp truly special. So one of it is that it's a dual mono design, and he has separate transformers for the left and right channels. And as you can see here, we have one power transformer and another power transformer here, one for each channel. And it's not just like separate transformers for each channel, but these transformers supply 6 discrete power supplies for each channel. So each of the stages has its own power supply, and that's what makes it truly special. That every stage has its own energy source, and they have much less crosstalk with each other. They can, when they drain an energy supply, they do not drain it from the other devices. And that's a really big consideration in amplifiers and in power supplies, that when you have energy available, then if you feed everyone with the same spoon, then you are gonna run out of food. But if you have separate spoons for each of the mouths that needs feeding, then you will have a much better result. If it's a tube amplifier, then in that case, if you have discrete power supplies, you will see like a tremendous increase in dynamics, bass response. But in transistorized amps, you see something similar, but there's something critical happens that's critical to solid state operation, is that you are going to see much less clipping and much less artifacts related to clipping. And usually for solid states, people only think about hard clipping, but the true danger that degrades your sound is the soft clipping. So that part that you do not hear, it's not like a gross clipping that the amplifier really messes up, because you want to make it perform at a high level, like not quality level, but a high sound pressure level, drive those speakers to 11 that it's not designed to. When you are running out of juice, that's a different scenario. And to prevent that, just get amplifiers that have enough power to drive your speakers for your needs. And if you don't have enough, add more. But if you have enough, then you will not run into that situation. But the situation you will run into without knowing that that's the situation is clipping on the transients. And those happen a lot when you have string instruments. So when there's a string plugged that has tremendously high energy transient response, which requires a lot of energy drained super fast from the power supply. So that's why the slew rate and stuff like that became like really big thing in solid state amp design, because you need to be able to drain energy and recharge energy really fast to prevent that really awful clipping distortion from getting into the sound. And this is not the case for tube amplifiers, because they do not get excited by these really high frequency hard clipping things. So with tubes, they have a super nice overdrive characteristics, and you have to drive them like 100 times harder into a transient than a solid state amp to get a response that starts to really impact the sound really badly, to make it unpalatable for the listener. So Michael Yee's solution to prevent that sort of scenario, which inevitably happens with any and every solid state amp, is that he uses discrete power supplies to make sure that there is no shortage of energy, and it really works. And in this case it works doubly, because he not just doubled up the transformers, so one for one channel, one for the other channel, but he uses EI core transformers. So when you buy a solid state amplifier, open them up at any price range now, you will find the Toroid transformer inside. And when you buy that amplifier, they will tell you, yes, you are getting the best deal ever, because Toroid transformers can put out that they are much higher rated in power than an EI transformer of the same size. So you think that, wow, now I'm getting something that finally has a 1000 VA rated power transformer. And you think that you have stepped up big time. But that's not the simple scenario. There's way more to know about that. Let's look at the transformer issue. So on the left side, that's how the EI core transformers look. That's what the Michael Yee amp has. So when it's assembled, it looks like this. You have these things here. That's basically the frame or the bulk of the transformer, and that's made up of these laminations. You see here, this is called an E because it looks like a letter E, and this is called an I because it looks like the letter I, and they are stacked on top of each other. And this part, when you have the wires, they are wound circularly around the bobbin, and they put the bobbin on these legs here, so the wires will be running around here, and then they get the E's and the I's and they put them close to each other, and then it forms a single unit. And the role of these E's and I's is to keep the magnetic energy, the magnetism, in that place, close to the bobbin, close to your coils. If you just have the coil by itself without this support structure around it, then it will still work as a transformer, but most of the energy will be lost. It will be radiated into space. So without the laminations, without the cores for the toroids, the efficiency is about 1,000 times less. So it means that your transformer here, without the transformer laminations, if you just have the coils, it would work only at very high frequencies. because there is not enough inductance to make it work at the audio frequencies or the power frequencies that we use. So that's why we need those laminations. And it does two things. One, it extends the frequency response low enough so we can use it for audio and power, which is also in the audio range, like 50-60 hertz. That's like a bass, a nice end of the mid bass or top of the deep bass, those frequencies. And the secondary benefit of this whole thing is that it keeps the magnetic lines that are produced by those currents that run through the coils, they are restricted in that space, so they are not radiated out and they are not polluting your other components. So that's one advantage of the toroid, which is on the right. So this is the most simple solution for a toroid. You see there's a donut core, it's like a ferrite donut, and around the donut there's wire wound around it, and here that's only one piece of wire. Those are the two ends of the wire, and in that's on top, that's a coil or a choke, so it means that's an inductor. And if you add a second coil around it, let's say like it starts here, couple of turns, other leg, so if you have a current running through here, then it will generate current in between those two terminals. And if you have more rounds for one, let's say that's the primary, is the one which is the source, and the secondary coil is the one where you have the transformed electricity. So basically a transformer changes the ratio of voltage and current. If the secondary has less coils than the primary, then you will have lower voltage, higher current. If it has more, then it will have higher voltage and lower current. So basically a transformer is a voltage current transformer device. And when we use a ferrite donut for it, and that's called a toroid, it means that that donut is not broken. There are no gaps in that donut, so it is like this. It's like a donut, and there's no like gap here or no breakage there. So it means that it's a gapless transformer. And if you do not have a gap, it means that it keeps all the magnetic lines within itself. And that's good and bad, because it keeps all the magnetic lines locally. That's why it has higher efficiency than EI lamination transformers. So it means that using the same weight, same size, a toroid can handle much higher wattage, like much higher VA number than a same size toroid. And that's the benefit is that if you are a commercial amplifier maker and you have a limit that your amplifier cannot be heavier than 15 kilograms, let's say, like 35 pounds, then if you use a toroid transformer, your power supply can be much bigger as if you were using an EI lamination. But what they don't tell you is that actually toroids are much more fragile than EI laminations. And the problem is that is also their advantage that they do not have a gap. That's their Achilles heel at the same time. Because why do we use gaps? If people knew this a long time ago, if you don't use any gap, so here is a real toroid. So you see there's the donut. We do not see the donut because there's wire wound around it, and you see those wire, those are the end of the coils that are wound. So that's what you see in almost every solid state equipment nowadays, and also inside CD players, decks. If your deck is high enough quality, you see these toroids inside, and not EI lamps that used to be the standard long time ago. And what people forget is that toroids is a step up, not in quality but in quantity. So you get more watts, but you only get them more if your power line is perfect. So if there's the slightest DC on your line, your perfect toroid is kaput. It's dead in the water. So, and it means because it happens because when there's a current flowing through your transformer, the current will make the particles of the core align to a certain direction. And because the toroid is gapless, so the force will make those magnetic particles align really, really strongly. And each second, like, let's say if it's like a 60 hertz line, like here in the US, then every times, like 60 times it clicks one side and then clicks one side back. So basically 1 hertz, like going up, the magnetic particles align north to south, and then they flip polarity, and they flip. So each of those 1/60th second, the magnetic particles flip 180 degrees in polarity. But if there is DC on your power line, and yes, there can be DC, so if you live in a very busy neighborhood and the electricity usage becomes really overloaded and unbalanced between the three legs of the three-phase power, then there is DC flowing, and it can be up to 1 volt, a volt and a half DC besides your 120 VAC. In Europe, this is much more rare. They take much better care of the power lines in Europe, so you can get away with a toroid in Europe, but in the US you cannot. Sometimes you can when the power is perfect, and then you feel that now my amp really has 1,000 watts if it's rated at 1,000 VA, but if there's DC on the line, you are lucky if you are getting 20. Not even 20, maybe 10. And that's because the DC polarizes all of the magnetic particles to get stuck in the same direction. And there's that 60 hertz AC going through, it cannot make those magnetic particles flip. So like 99% of the magnetizable material is stuck in place by the DC, and they are not allowed to be flipped by the AC. And that's why there's very little going through and picked up by the secondary coils. And if you have a gapped transformer and all of the EI laminations are gapped to a certain degree, then because of that gap, it allows you to have a certain amount of DC running through the system before your transformer locks up. And if they are stuck like this, so all the I's are one side, all the E's are on the other side, that's called a gapped EI transformer. And typically you see this only for the output transformer of single-ended tube amps. So that they are not doing this in power transformers, because that really means like multiplying the size of your transformer tremendously. And that's not practical because transformers would be so expensive that no one would be able to, actually people would be able to buy them, but the market pressure drove all of these attempts off the board. But if you want to build the ultimate amplifier, then make a power transformer that's gapped so that it can handle up to, let's say, 5 volt DC on the power line. Never ever will 5 volts DC appear, but if that 1 volt DC appear, then if your iron is gapped to 5, you will not notice any difference. So that would be like one of the best ways to take care of weak power supply situations, is to design a transformer for your amplifier that's capable to handle DC. That's the ultimate solution. However, because of practicalities, all of the EI transformers that we have in our amplifiers, they have interleaved gapping, so they have one E on this side and the I on that side, and the second one E here, I there, so they are flipping, and then it has so tiny gap that it's almost gapless. I would say almost. So it's not really designed to handle any DC, but if you have that 1 volt DC going through the line, that's still at a current low enough that it doesn't lock up the entire transformer, and it still leaves quite a good percentage of it available to translate that 50 or 60 hertz electricity. And that's not the case of toroids. So that's another key attribute for the Michael E, is that even though it's just a 50 watt per channel amp, in most cases it sounds much more powerful. And that's because you can have your 1000 watt per channel amplifier with your massive toroids, but if you live, let's say, in Waikiki, in one of the high rises, you are lucky if it can give you a 20 VA on an average day. So that's why numbers don't always mean something. And when you look at an amplifier design for a solid state amp, especially if you see EI core power transformers, that is actually a good sign. And that's what you see in many of the high-end solid state amps even today. And if the designer is really thinking about practicality, not just has an idea about what is the state of the art, and we designed for a unicorns flying scenario, but for a real human being who uses it in his own house with real world conditions, then you cannot beat a properly sized EI transformer. And if you want to have a 1000 VA core, then just put on an EI transformer that can handle 1000 VA. It will be huge and massive, and the total weight of your solid state amp will probably double. But that 1000 watt on the logo, that will make much more sense, and then your amp will be able to perform under difficult circumstances as well. So let's come back to the layout. And as you see, layout is really critical for any amplifier. And then you see that the transformers, those big bullies who generate those really strong magnetic fields, they are really far away from the power transistors. So what they radiate is far away from those devices which are sensitive for that radiation. And you also see that the power supply filter capacitors, the big ones that supply and clean the majority of the current that your amplifier is using and translating into sound, they are also neatly separated away, far away from other components in the board. And one thing that doesn't show up here, I wanted to show you guys, but my camera decided to act up and die, so I had to do this video instead. And so that when the amp is operating, even if it's been on for hours and hours and hours, you can touch a transistor, hold your finger there, and it doesn't burn you. It runs cool enough. So it means that it has adequate heat sinking to make it operate at a temperature that is beneficial for the transistor. Because you have to know that every electronic equipment, every part, transistors, vacuum tubes, chips, capacitors, all of them, the number one thing that limits their lifespan and causes trouble for them is temperature. And if you make sure that your temperature doesn't soar, then you can ensure a very stable operation and super long life. And this is happening here. So Mike has designed this amp to be super stable. He's not stressing out the parts, so you don't have to be afraid that if there's a power surge, then your amp will go up in a smoke, or you don't dare to crank up the volume to 11 because, you know, what if there's a surge or something happens and it will blow? It will not blow. You can run it full power and it will still think, okay, I'm taking a walk in the park because I'm not stressed out. when you see these nice big power resistors under, when the amp is going full blast, I can touch them and hold them. They are not hot. They are warm, yes, but they're comfy enough so I can hold them. In most amplifiers, when you have these power resistors, if you just touch them a little bit, your finger is burned to a crisp. And here I can grab them with both fingers and I'm fine. So Mike really knows what he's doing, and he designed this amp to last a lifetime for you. So when I look at solid state equipment, most of the time when I read the logo, it doesn't say the brand name. In my mind it says landfill, because unfortunately their lifespan is really limited, and you cannot repair them, because after 15 years or so the transistors go out of the production run and you cannot replace them. So if you are curious, you can look at there's a lot of videos on YouTube when manufacturers are talking about the replacement parts, replacement transistors. Like look at my Nelson Pass's interviews. Then you will know that that's the limit. So that's why many companies have to stop producing their successful amplifiers, because the transistors are made no more and they have no more access. So that's why Nelson Pass is showing you that I got like 3,000 of these JFETs here in stock, so I can make more amps if I want to, or if there's an amp that needs replacement, I have replacement parts. But for 95% of the companies, for almost every model that you buy, if you want to have repairs after 10 years, 15 years, you call up the companies, they say, I'm sorry, we cannot repair it for you, maybe we can trade it in for you, and you get something else, and then it will go to a landfill. So I have seen that, unfortunately. I tell you guys this story, that when you buy an amp and then you decide, oh, maybe I want to upgrade, whatever, and then you bring it back to the dealer and they give you maybe like $100 credit or 200 or who knows what, euro, whatnot, credit to count for the price of a new amp that you are getting. What happens to the old amp? If it's still functional, or maybe not functional but needs repairs, maybe the dealer can repair it and then sell it real cheap to another person who will be really happy for that, maybe another 5-10 years. But then it craps out and there's no more parts, and then the dealer will still take it in because he might use it. That's what Stu did. Like he had like tons of things, and even if something was burned out as a toaster, he still kept it because maybe someone would need like whatever knob, volume control knob, because sometimes it happens. Maybe the dog runs away with your volume control knob and you need one, and there's one. But what happens when that store owner has to close down business? And that's what happened to 90% of the stores in the US. They had to close down because of the really bad economy during the past 15 years. Or when a store owner dies, that's what happened to Stu. And then we took 100 truckloads of waste parts and electronics to the landfill. 100 truckloads. Can you imagine? It's like a gigantic monster shock. So that's why I see landfill when I see solid state gear, because that's where they go. And when we did those landfill runs, there were barely any tube equipment in there. It was all solid state basically. And that's why I really appreciate what Michael Yee does, because he makes his amps last a long time. Okay, what else would I want to... Oh, number one thing. You also probably saw it when I showed in the previous videos, the PA1, that I took off the cover. And part of the reason was to let you see what's on the inside, what makes it tick. But the other reason is that there's a purpose in removing the cover of your amplifier. I think if you went to enough audio shows, then you have seen probably a bunch of companies do that. And if you have keen observation skills, you probably have observed that those rooms which sound the best, they tend to have the covers off their equipment. And you think that in those cases, then the owners are when confident enough at the performance of their equipment that they dare to remove the cover and show it. But it works two ways. So when you have an equipment cover that's a metal cover, it adds capacitance. So all of those electric fields, everything that's generated inside the amp, it gets picked up by the cover, and it gets basically radiated back to all of the parts. And when you remove that metal cover, then basically the sound opens up. You have much less capacitance added back to the signal, so the high frequency, the top end, becomes soaring much more. You get more dynamic headroom and a cleaner sound. And you can do it with any amplifier, but if you live alone and you are responsible and you know how to work around electronics, you feel comfortable with it, then you can do that. But if you have like little children or people visiting you, then do not do that, because maybe there's a toddler reaches inside the amp and drops down dead. You cannot. Even though solid state amps have lower voltage power sources, they rarely go higher than 50 volts. They have enough current capacity that a young child can easily die if they touch the insides. So if you have that kind of situation, then do not uncover your amps, and if you uncover, do it at your own responsibility, and you have to be aware of it and very vigilant, and no kids allowed. And I would say that it's dangerous for pets as well, maybe rabbits, because they want to chew on everything. Cats, they are smart. They feel if there's high voltage in those parts, they will not go there and get zapped. I have cats, and I have experienced that they would not chew on things or touch things that have dangerously high voltages. But they would easily chew on those parts which run like a low current. That's not dangerous for them. They might tear that up, but they will not zap themselves. So basically, for those people who knew Stu, my mentor, in his shop he had removed the cover of everything. It's just no covers. A lot of time he even lost the covers of equipment. That became kind of a joke around him, that if you brought in an amp for repair, then probably you got it back. You were lucky if you got it back with the top, with the cover, but probably a couple of the screws were missing. So anyway, that's something. Now let's look into it, what amps I would like compare it to, and how the comparisons stand up. But let's look at it after a little bit of a break. And let's cut for a break.